All right. Good morning or afternoon or wherever you find this. I just had sort of I don't know, if this might be a moment of genius or just a madman's rambling. I'm not quite sure here. But I've been thinking quite a bit recently about AI agents and how they want to work, developing as I am the application to, to do that sort of thing. And I think I've stumbled upon what I think is the next kind of logical step in the progression of both where I'm at with the app and maybe just kind of where the industry is as a whole in terms of how to actually kind of meld uh, kind of more traditional programming with AI and how to kind of get the best of both worlds in one language. You can almost think of this a little bit, if you're familiar with such things, as like the JSX of this sort of stuff, right? Where I'm combining kind of two paradigms, two ways of looking at the world uh, in one place. And I think what I've discovered with JSX is that allows a lot of freedom and control in programming, like React components and so forth, like the web programming and so forth. And I think there's a similar little bit of magic that can happen if you kind of take that idea and run with it with AI, because it feels like there's two different kind of paradigms and styles of programming. So let me just kind of run over the paper here real quick and explain my reasoning behind it, kind of at a step by step thing. Let me turn off my virtual fireplace. Maybe that was, I apologize if that was in the background. Um, but yeah, let me just go over it. This is gonna be kind of free 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 flow thought. So I apologize. It's not gonna be real tight. Maybe listen to this at 2x speed or something. But anyway, let's just go with it. I have a full thing of coffee, so we're good to go here. All right. So my vision for this is that it's a programming language for programming AI agents, right? And in the application right now, we kind of call them characters or agents, but they're essentially these things that use LLMs to kind of animate themselves in some way, right? And so the difficulty I think I've faced, right, is in trying to kind of control the agents. Like you need to have some sort of way of having the agent do what it wants to do, work on your behalf or have a conversation that is this kind of person or something like that, or this character. But you want to have control as you do it, as the agent author, if you will. And so there's kind of this balance where if you just give the agents kind of small direction and prompts in the system messages, the AI does pretty well as far as like being able to hold a good decent conversation and kind of follow goals and patterns and so forth. But you kind of lose a little something, right? Because as the agent author, you want to kind of be there as the agent's kind of working on your behalf. And when the agent kind of has this fork in the road moment, you want to kind of direct them down a certain path, right? You want to kind of take the reins a bit and make sure that they do a certain thing. And so currently we have this mustache-like case insensitive templating language. I'll kind of go down a little bit more towards the bottom about how the syntax for that is. But if you're familiar. And so I'm building upon that. So that's staying, all right. But I'm adding to it more programming like features. And that's kind of what I've come up with here. So the key thing here is this. Let's see, is the highlight going to show up? It's really ugly. But anyway, this section right here, I'm not going to do that because that looks really ugly. But there's a balance between APL, AIPL between hard code and what I'm calling soft code. So hard code is kind of more traditional software development coding, right? There's strict, rigid syntax rules, and you know what's going to happen, right? It's kind of the whole point in a sense, right? The machine just does, it's kind of very dumb, and it just follows your directions, no matter what, right? For good or bad, right? And so that's what I'm calling hard code. And then I've come up with my own little term of art here called soft code. And soft code is more what happens when you do like the what's called function calling, right? In with LLMs, where essentially you give the AI a function to call that it knows how to call, and because the LLM has been trained on a vast, corpus of excuse me, of code, like software code, like programming languages, it knows how to call a function, right? And so you're kind of using that as kind of a trick to have the LLM call a function within the context of the conversation. And it's not 100% reliable. It's obviously you're kind of mixing metaphors, if you will. Excuse me, boy, I got a little frog in my throat here. I just woke up, so. But so it works good enough, right? It does interesting things, and it's good enough. But it's like I said, it's soft code, or it's what I'm calling soft code, because the AI has the facilities to be sort of non-deterministic, and in particular, what it's going to give as arguments to the functions, right? So a good example is you'll generate an image, right? So you'll have a function that generates an image, and the AI will call that function. But typically, you're going to say like, give me an image of a cute cat or something like that, and then the AI is going to put into the arguments of that function something that will generate a cute cat, and it might be a kind of a very creative sort of prompt that it might come up with on its own, or it might just be a very simple one called cute cat. But it has a lot of flexibility and control in what the arguments are it's going to give to that function, and that's kind of where the creativity happens, right? So I'm going to take that a one step further, and I'm actually going to have the AI evaluate the code, and that leads to some interesting paths, I think, right? So it's not just calling it; it's going to evaluate it, and that's the key thing. Like, what does it get back on the other side, on the return stroke, right? So I'm assuming that you can read, and so I'm not going to go over this line by line, and hopefully you're reading this. So there's kind of three key elements of software development and programming and so forth, or at least there's the three I'm going to focus on here. Those are state, events, and logic. Okay, and those are like big weighty terms. So state, like how you handle state is kind of like everything in a sense in the programming language. Like that's the difference between like a functional style programming and a more imperative style and so forth, right? It really makes a difference. And so for our little programming language, my little programming language that I'm coming up here, uh, it has a very simple state. And I have it here kind of described, kind of using a TypeScript syntax. So forgive me on that. But it's sort of, I have these little objects, let's call them, associating with the chat, right? As the chat goes along, these little chat data elements, objects, whatever you want to call them, are going to be associated with the chat, right? Now, they themselves are immutable, right? And I'm just going to build them up as we go along. But the user will have access to sort of like the most recent, idea or the most recent value associated with this chat data. So, as far as like how the system functions behind the scenes, it's all immutable. But as far as the kind of the user of the programming language is aware, it's mutable, which means it just changes over time. You can just update it, right? So now I have a little. It's the values, right, are a little bit more complex than kind of a traditional programming language, like especially kind of like how you name them, how you name your variables, because I think that's very important. And so I have this concept of a name space, right? So each variable will have a namespace. So here, let me highlight this section here. That's really killer, really important here. This little area right here, right? Namespace dot value. Now, namespace will be whatever you want to have. The report dot, TPS report dot, was Bob late? Whatever. It'll be two. There's a namespace and what I call a key over here, right? Separated by a dot. And so that's how the naming works in it, like how the user has access to it in the template. So that's kind of how state works, right? You have this concept of a namespace, things fall under, and then you have these key value pairs that you can set inside the namespace. Another thing to note is that everything's a string. I think that's just part of that is just it's easier, but also fundamentally everything can be serialized to a string. The string is sort of the ultimate data type in a sense, right? So that's the one we're going to support, and I don't see a need right now to go beyond that. Maybe later it'll be interesting to do so. Maybe not. There's also this idea of currently in the kind of what's called the top level structure of a type. That might not be a thing that a user gets to see or have access to, right? But this is kind of like under the hood, because obviously this code exists today, right? This is how I'm doing things behind the scenes inside the application. And so I'm just kind of ripping that out. So type is interesting from the system level to distinguish different kinds of data to be used in different ways. That might not be an interesting thing as far as AIPL, as far as a programmer of AIPL, because they'll probably never have access to type. But anyway, I guess I just had it there, so I just wanted to explain it. Yeah, here we go. I give a more detail about that. Events. So you need an entry point, right? Like any programming language, and every programming language on Earth, right? There's a main, right? Which is your entry point into the how the system does what it does. I say every programming language, not obviously every programming language does everything the same. In particular, we don't have a main, right, with AIPL, because that doesn't make a lot of sense. It's not like an imperative programming language or something like that where you're going to do stuff. So this is an event-driven sort of language, right? So as the conversation goes forward, there are going to be certain well-defined events that happen, right? and the user of the language will effectively, create event handlers that will do stuff when an event, fires off, right? So I have, lots of different things about events, like, they follow the URN naming convention and stuff like that. That syntax stuff, I'm not trying to get into the syntax right now. I'm just trying to get into the high level, you know, how it all works. The probably the key thing to note here, though, is that there is some room here for what I'm calling outside events, right? And then I have the example here of, like Hal, right? Oh, just a moment. I picked up a fault on the A35 unit, right? We're all going to die. There could be something that happens during the course of a conversation where the agent has access to new information that it just picked up or what have you. And so it might even interrupt the user, right, as they're speaking, or it might, do something like that. So there's some real opportunities here to make the agent kind of come more alive in a sense. Let's see, what else is interesting? So this is the basic syntax of what an event looks like. This is what I have currently. I don't know if this is going to be the final syntax or not. This is just what I'm playing with right now. It's going to have these components, though. Whatever I end up with at the end of the day, as far as the little syntax markers and so forth, this is how it's going to kind of be, right? We have an event, we have a condition, we have what I call a state location, which is essentially that, where you're going to shove the data into, right? On a traditional programming language, it'd be the thing on the left-hand side of the operator, right? And then what I call a state question. And this is kind of the interesting part where the LLM gets to answer a question, right? So this is where it's kind of, we're starting to get into where, there's some non-deterministic stuff, and we're kind of leveraging the AI or the LLM effectively, its ability to kind of do things, right, and affect the program. And so we have this thing called a state question, which is essentially the bit of text that you're going to put in there that the LLM is going to answer, given the context of the entire conversation, right? So whatever the conversation history is, we're going to get that, hopefully as much as possible. We might have to do some tricks, it's all depends on the context size and the length of the of the conversation, but hopefully we'll be able to fit it all in memory, or if not, it'll just be the most recent or something like that. But anyway, so we have events, conditions, state locations, which is where you're going to put the data, the answer, and then the state question. Now the condition is optional, so if it's not present, it's assumed true, right? It assumes that you just want to do this every time this event happens. But if it's there, then it gives us this is kind of the real magic in a sense, I think, because this is where this condition is not a traditional what I'm calling a coded it's not hard code. It's what I'm calling soft code, which is to say that here's the example, right? This is soft code, right? So this part is hard code, right? This is like there's syntax, and you have to have the little open ellipses and then have some stuff, and a close ellipses and question mark, and where you're going to put it, and a little arrow thing, and then the data, and then you have to format the all your variables correctly for the prompt, the templating and all that sort of stuff. So that's all kind of like, that part is all pretty hard, right? You have to get your syntax right, and it has to be good, right? Because we're going to evaluate that in kind of more traditional now machine code, right? And then, but this part right here that I have highlighted is this part is what I'm calling soft code. And the kind of the brilliance here, or maybe brilliance, we'll find out, is that Boolean algebra is very powerful, right? Like you wouldn't think that it would be that powerful, right? Because it's so simple. But I guess maybe sometimes very simple things are very powerful. And by having this condition, which evaluates to just a true or false, right? That's all it does. That's all it can do. So it's either go or no go, right? By having this and having the LLM evaluated, right? So this is an example of what the prompt might look like to evaluate that bit of soft code, right? By doing this, we allow the LLM to kind of do what it's good at, right? Which is this sort of soft, fuzzy kind of logic, right? Like as a human, like as me, right? Programming a function called happy, right? That took in this data, and then I had to determine whether or not this string of text, right, indicates that someone's happy or not, right? And it's not even like that well defined. What does happy kind of mean? Like who's happy? That there's a lot. Like I'm very sloppy in this code, right? But you kind of understand the intent, and more importantly, the LLMs seem to understand this intent, right? So I've run this through some LLMs, and yeah, they seem to perform pretty reasonably on this sort of task. And this, I think, is the crux of it. This is the kind of the almost the this is it, right? This is the interesting, good idea that I've hopefully had here. This evaluation step, right? And this combination of soft code with hard code, right? And I think that what this does is this thing right here allows the user to kind of use the LLM to modify the behavior of the agent, in quote unquote real time, right? As the conversation is happening, we can flip these, we can modify the state, and then the state can be used within the templating to drive different template system prompts that you would give to the LLM, as it's evaluating what it wants to say on the next kind of its next utterance, right? It's the next thing it wants to say to the user. So this is a lot of work going on here to for the LLM to what is it going to say next, right? That's kind of the big. That's the hard part, right? That's what we're trying to achieve, is for the agent to behave as the agent author. I kind of like that, alliterates. Agent author intends, right? And I think this gives some good control to the agent author to as far as what it should be doing, because you essentially need to control that through these system prompts, right? But you also need kind of a programming language that allows you to kind of modify those system prompts depending on different states and if different things happen and so forth within the conversation. You need to have some more traditional programming tools at your disposal. It's no wonder that you need that, because that's why we as humans created programming language, right? That's why programming languages have the structure they have, and we kind of need them to control the what used to be kind of the dumb silicon, let's call it. Well, that's really the way that we, I think, want to control let's call it the smart silicon, right? The agents that kind of are more creative and kind of, more undeterministic, and, but they're kind of doing their own thing, right? But you still want that level of control, right? You want to have some sort of ability to guide the agent along its path, right? Let's see, anything else interesting here that I want to talk about? Yeah, so the mixture of hard soft code allows for faster development, as no real code is ever written, right? So that's a key element here as well, right? Like, right now the thing is, software developer, right? So the big thing is, you have all these plugins to VS Code to, help you write code and so forth. Actually, I don't do that. I'm more old school. I just use various chat interfaces, but whatever, that's just me. The But the key thing here is that, it's essentially like, at the end of the day, there's hard code that's written, and then I have to like take whatever the LLM generates and then stick it in my program, or, obviously, there's massaging that happens, let's say, along the way, because 9 times out of 10 it's not perfect, or it doesn't perfectly interface with what I'm trying to do, or doesn't follow some coding standard or practice I want to follow. But it's real code that's going to run, right? And so the LLM generated it, and it's real code that's going to run. But it's kind of a unnecessary step in a way. It's sort of it's almost the difference between like a statically compiled sort of language and an interpreted language in a way, right? Like an interpreted language, like it's kind of more real time kind of thing. Like as the program's running along, it kind of evaluates things and goes along, right? So that's the reason why these programming languages that are, follow that, and have a strict compile step, they're kind of faster, right? They you can be more kind of productive with them as a developer, because it kind of skips that. You don't have to wait on compiles. Although, obviously we've reintroduced that with TypeScript. But anyway, that's a story for another day. But the key thing here is that what if you didn't have to write that code at all, right? What if that code didn't have to exist anywhere? What if you just program? What if you just had these, what I'm calling these soft code, little bits of soft code, right, embedded in your hard code, right? And then you don't have to, here's your hard code. So you've got your more traditional programming, your Rails, your guardrails around that, right? But then you just pop in what the AI of the moment of the day when this is running, thinks about this, right? And so you don't even have traditional code in your code base, in a sense, right? It's just like, and here's where I would put that function if I were to write it, that sort of thing, right? It's just sort of like, and here's where that goes, and here's the space for where the LLM can be creative and do what it needs to do on the day. And hopefully, I say on the day because, LLMs are getting smarter and better and faster and all that sort of stuff. So the code, the LLM that evaluates that today in my development environment, is likely going to be, kind of stupider and slower and not quite as good as the LLM of tomorrow or next year or a decade from now or what have you, right? It's just this is almost like the opposite of bit rot, right? My anticipation is that the soft code will actually improve over time, right? The evaluation of it will get better and better. Now, we're not quite at the point where, it's perfect, and it's probably never going to be perfect. And we need to and that's kind of the, bridging the gap between these two, is Mr. Boole, right? And I think that's maybe another key thing, right? At the end of the day, there's sort of like this, I think the happy bridge between these two worlds is Boolean algebra, right? Where essentially, you know, I don't want to I don't want this to evaluate. So, for instance, you could have this section of code evaluate to a string, an integer, you know, what have you, right? Why did I pick Boolean, right? The reason that I think it's important that this goes down to a Boolean is because there's really no argument about a Boolean, right? So it's similar to a string, and you know, strings are kind of like this ultimate high level data type, if you will, that kind of encapsulates everything. Well, a Boolean is kind of the ultimate low level data type, right? It's kind of the opposite end of that spectrum, where there's really there's no room for misunderstanding in a way, right? And so that's why I think it's important that these soft codes, bits of soft code, kind of evaluate down to a Boolean. So that maybe that didn't come across as perfectly as I want, but anyway, I think it's very important. I guess that's I can't really quite explain why I think it's so important, but I think it's very important. So other parts. Let's see. Prompt templates. So this is just more how you would use this in practice, as far as an example of a system prompt here. Of, you know, you'd have the car, you know, which is the current character's mood, and what it is, and then, you know, you'd obviously have some defaults with it, and then, or you could have some defaults, I say, and then you know, you use these state variables inside the template, which is then evaluated as the conversation happens. And so that's how that would it all kind of feeds back into the system prompts for the agents, right? Which are effectively the instructions for the agent, right? So you're essentially reprogramming the agent as it goes along and does its business. So that's how it it all comes back together, right? Is you're kind of rewriting the instructions for the agent, right, via these system prompts. And I'll just let the document kind of speak for itself, because that's just syntax. I will say that I'm happier with the syntax, so this is probably going to be what the final form is going to be like. But and that's it. That's all I've got so far. I'm going to spend the day, and I'm going to make this real. I'm going to just code it out. I've got most of the pieces right now already there. I already have the idea of an event. I already have the idea of, obviously, the templating and so forth. The part I don't quite have is the syntax around this, right? This is new syntax. So I need to parse and so forth and do the right thing. This is it's the hard part. The hard part here. The hard part is hard. So anyway, that's where I am, and I think this feels good. I think, you know, given the history of you know, where we came from, and where we are today, and the pain I've felt over the last several months trying to you know, code up an agent and kind of have that balance between control and you know, letting the agent be creative. I think this strikes the perfect balance. I think this, like, I don't know in the future if people are going to be coding with my particular little programming language, but I'm pretty sure that this idea of the hard code and the soft code is going to stick. I think that feels very very good, right? It feels like I, as a developer, you know, I don't, that reduces the burden off of me to do this AI stuff and it does it in a way that is very accessible and easy for me to deal, to reason about. And I have my traditional programming language, and I just kind of have this little section where it goes out and does the soft code stuff. So, obviously I have a syntax around this and everything. So other languages, this could be a function call in some other language. So I'm not certain that my syntax is going to dominate the world or anything like that. But I think the idea of having something that kind of reaches out and does this soft code stuff and returns effectively Booleans. I think decision points are the key thing here. Branches, right? Um, I think that's it. I think that's the cool part. Anyway, I've been rambling on now for how long is OPS say? Half an hour, 35 minutes. So anyway, hopefully you got something out of that. That was probably just more me talking to myself than anything. But I am pretty excited about this, and I do think it's going to open up some good possibilities. And anyway, I'm excited. I'm just gonna code it up. Catch you later. Bye.